So I'm going to talk a little bit about how to protect and shield your Java application with some a security practical guideline using secure software supply chain practices and platforms. So my name is Daniel. I'm from Red Hat, from Boston. Couple hours flight here, and then I don't know how many times I'm the Devnexus, maybe 4. I don't know. I'm a Java champion and developer advocate. Focusing on cloud native runtime, Quarkus, Java, Spring Boot, JavaScript, and then outside the Java is AI, like GitOps, security, serverless, among others. I've been a long time to CNCP ambassador, which gave me a lot of opportunity, bring more application into cloud, like Kubernetes, and such like a security software supply chain, and yeah, here's my social media handle, Daniel30. So there are many Daniel around the world. So I have a Doris Daniel. So yeah, you can Google me, Daniel in Google, YouTube, any social media, and then find me, and then ask me whatever you need, and then happy to help. So I generate this freaking scary image from ChatGPT AI stuff. For because you probably know, if you already have some more than 8 years or 7 years of Java experience, you probably aware of this kind of Java security issue back in there. So back in 2017, there was Equifax company. It's a multinational American company to serve credit bureau, something like that. And 8 years ago, they exposed personal information such as a social security number and credit card information around the world. I think it's more than 143 million records, which is huge. And then in order to recover that security breach, they spend more than $1.5 billion. It's a huge. It's some Java issue code at a time. And a little bit recent, back in 2021, 4 years ago, Log4Shell is one of the big security issues back in there. So there was a malicious code, no, it's not malicious code. It's what is it? Yeah, the malicious logging entry was hijacked in the global system. Not one company like Equifax. It's any company around the world use the Log4Shell, they got some impact. That's why the cost, the loss cost was more than $10 billion. So it's another huge issue. And more recently, there are many Java and Spring developers. So Spring 4 Shell got some security breach at a time, 2022, just 3 years ago. So it's a little bit less than because only Spring, not general Java. So Spring MVC, at a time, there are some unsafe binding code happen in the Spring MVC, not Spring Boot. So it's around the world, $50 million more or less. So we got some lessons to learn from history. So one small line of code or a couple lines of code maybe code security breach, and then it huge impact your economy, a budget in your company. That's why every single time, your security team, maybe they say DevSecOps team, they actually ask individual developer, you need to make sure everything is secure, not only application features functionality, but also application already secure. But the problem is individual developer actually doesn't care about it because I don't have enough time to secure my application, just want to keep doing my job to implement business services and a bug fix or a little bit of performance improvement, something like that. But that's not always a bad thing. In the meantime, we have great technology, not only overall cloud and general, but also specifically Java technology keep evolving to facing the more smart and more complicated security issue. So here's just some kind of, I like to some Japanese enemy stuff. And then just let me a little bit break down what kind of technology we had and then what kind of technology we will have for the Java security. So back in there, like a basic security, also you can say legacy protection. At a time, we have a very fundamental basic security capability in the Java application. For example, like a password-based security. If you wanted to access some Java resource, you can just type in right username, password, your credential. So back in there, like a Java security manager is already deprecated all the time. And then JS, Java authentication and authorization services, which is another thing, kind of thing. And then technology a little bit evolving into strength and dependency. And then at a time, it's rather than like a basic password-based security, it's more like a API level and secure coding practice approach. So with that, Java also gives some more great like a library and feature and capability, like a JCA, a cryptography, and like a Java security socket extension. And then we also needed to pass through and coming through all like a sensitive information using like a HTTPS and TLS encryption protocol and so on. It's a back in like I would say like a decades ago, something like that. And then we arrived more like a automation stuff to secure thing. It's a rather than API level, rather than coding practice, it's more like a fundamentally secure your Java application based on framework and platform level and some of the some core library. So which means it's a more convenient for Java developer. Okay, I just use some like a secure library, like a Spring Security. I add Spring Security as an ecosystem on my application. I just make everything is secure, my application, and OWASP dependency checking for like a vulnerability, CVE, XYZ, or you can use JSON WebSocket rather than plain text. So pretty much easier for Java developer to use framework and library and software component. And now we arrived at AI. You probably saw and watched a lot of AI topic and session in the last couple of days, even during the workshop stuff. So inevitably, we need to use the AI. Doesn't matter, you're gonna develop like a old traditional legacy application or a fancy agentic AI application, you're gonna use AI inevitably. And then AI-driven security monitoring, in this case, it's a little bit beyond your simple Java application. So whenever you develop Java app and deploy somewhere environment, you probably interfere by AI's capability. So AI keep monitoring and detecting some abnormal stuff from your Java application. For example, I just implement like a DAO, DTO, like a data transaction with Oracle database or PostSQL. And then there are some like a SQL injection or some of the like some breach logic in there. And the agent AI application, like a predictive AI, automatically detects some abnormal, unusual stuff, and then report it to like an IT operation team, and then they will make a phone call to you in the middle of the night. Hey, Daniel, something happened. You need to fix that problem right away. So this is a more AI, and then like a more runtime application, a little bit have a self-protection. This is AI, and then threat detection. Pretty much a predictive AI, a little bit Gen AI stuff too. But that's not the end. We also more great step, which is more futuristic and the zero trust security. This is a little bit, I'm going to talk about it more today based on secure software supply chain using SBOM software, the bills of material. The SBOM includes all ingredients you're like a meal, like a cooking stuff, all software thing. In the zero trust architecture, this is a very interesting because fundamentally the GTA never trust, always verify. That is a fundamental pillar. So whenever you develop app and you never ever trust any external services. You always verify that, like a validation check or some unit test, whatever you call. Even in AI application, you probably need to add the guardrail capability for the authentication and authorization stuff. And the GraalVM, you probably know GraalVM is a native compilation, executable, and like a Java, there are great features to provide the Java developer an application. For example, fast startup time and small memory footprint. But not only that kind of feature, but also the small memory footprint, it fundamentally eliminated some dead code, which means that you don't need to have a full JVM stack. So small size of runtime, which significantly reduce the security surface and breach. So that's why GraalVM, the executable image, also great application packaging to secure the application. So what kind of practice as the Java developer we're gonna take from here along with the evolving technology? So there are three main some phase or step, pillar, whatever you call that, for along with your software development cycle. Probably some of the part relate to your inaudible process, like a writing code, build code, testing code, back to the writing code, and over again, repeatedly every single day. And then a little bit build status is not only your local build, but also like a containerizing, and then more like some targeting testing environment, a little bit between inner loop and outer loop process. And then last step is more like keep monitoring for security at your runtime. It's more like your platform engineer primary job, but if you could understand how that works and then what that looks like in the after like a day two operation, it pretty much helpful for your daily job when you secure application. Because at the very beginning, I showed some security issue back in there in our history, which means if you protect that application in advance as much as earlier, you don't have to fix that problem. You don't have to get some alert when someone detects your application during the monitoring your production environment. So let me really bit break down and take a look at the little bit detail. So starting with the trust content, which means you need to have like some trust to like a base fundamental thing. Could be like your runtime, like, oh, I'm gonna use a Java, but I don't want to you probably not use to like a Java 11 or even 17, maybe more latest version, better performance, better functionality, and then better secure. And then if you want to containerize your application and eventually deploy application in somewhere cloud with the Kubernetes, you probably use like a trust the universal base image. In an application library, like a Log4Shell or some of the library, you probably avoid use that kind of stuff. Even if you just need your local machine just to testify application, probably you to get rid of that kind of stuff. And then there are some like open source tool, like a SigStore, gives a lot of CLI and command line tool to signing your application and verify and test, as well as generate the signing key at the same time. So there are, when you go to like a code status, you can have like the security tool and integrate into your Prepare ID tool. Can be IntelliJ, can be VS Code, maybe some people still using EclipseJ. And then there are some extensions. I'm going to show a really quick demo in the right away. I probably use like a VS Code on the cloud environment as a cloud IDE. I'm going to quickly add like a VS Code extension to analyze, like some detect your static code or some like vulnerability stuff. And then once the code phase is done, you're going to move to the build the application. So build application, you probably know there are many build practices based on CI/CD continuous integration and continuous deployment. And then not just integration, like testing or containerize and push some container registry and then just deploy that kind of thing. Rather than that traditional CI/CD, you probably add on like scanning your image and image checking, or their integrated secure software supply chain, or you can say trusted software supply chain with some software chain level for the supply chain level for software artifact, aka SARSA, and as a station and using SBOM. So I'm going to a little bit explain some more detail around image checking, image scanning, or deployment check as a part of secure supply chain. And then you can see there are open source tools like a Tecton. It's owned by CNCF, the Cloud Computing Foundation project. It's to give some stand of your CI/CD pipeline. Everybody have so many different CI/CD pipeline like Jenkins or Circle or GitOps and among others. But the Tecton is originally provide the Kubernetes way. So let's say, oh, I have many Java application or JavaScript.NET Python running on Kubernetes. And how do I deploy this application into Kubernetes using CI/CD? In that case, CI/CD probably or should be running on Kubernetes as well. And then how do I do that? Oh, I have a Jenkins. Okay, I need to containerize and deploy Kubernetes. You can do that. But you still need to like some Jenkins, some script, and like some program language stuff. But the Tecton, you can define like a Kubernetes manifest, just like a YAML file, just like other application manifest. Exactly same way. That's you. There are more Kubernetes way. The standard manifest running on Kubernetes, like here the 6-store clear image scanning and the texture chain, supply chain, that kind of stuff. And then people needed to using some digital key to sign application. So if you have some Java application like a Spring Boot or Quarkus or just plain Java, and then once you test and build and then try to containerize that, and then you need to certify that container image. Oh, this container image is secured. And then once you secure, how to mark this is really secure. You don't need to just add tagging 1.1, 1.2 version. You need to secure and then certify with some digital key. The like a 6-store open source tool, they generate certification key. And then once you secure container image, and then you can put in that key on top of the container image. So key you can generate yourself using CLI, or you can use external the key and value management system or tool like a HashiCorp, Vault, or Azure, Microsoft Azure Key Vault, or even use your hardware like a flash drive, like you can put in your laptop. You can save all your credential, password, access to Netflix or Amazon.com or your local anyone. You can just use the flash drive as well. And then today, a lot of company and some people use keyless signing because when you generate new digital key, it's like a long-term usage, like a 1 year or even 2 years or even forever. But even if, as long as you have the same key for a long time, you got a more chance to be like a breached, some kind of vulnerable. So that's the short-term period for like just signing your container image, and then after that, and then verify and deploy that. I don't need to use that key anymore. In that case, you have probably short-term digital certificate key with the keyless signing stuff. And after that build, we're going to deploy application. And then not just deploy to application containerized stuff into available Kubernetes. You also need to other thing like the YAML policy checking or image policy checking or enterprise contract before you tagging your application container into targeting environment. And the last step is not primary job, absolutely not for the normal developer, but you probably need to understand what's going on in there, because someone actually from platform engineering team finds some security issue, they will report back to developer team about the security issue. So that's why you can see there are also like a scanning, keep scanning and checking, and then like an enterprise contract checking as well. So this is just some kind of conceptual pipeline and development process from beginning writing code and the build application and deploy application, and keep monitoring based on Kubernetes. And like a Java, could be Java application, it could be other application like a Golang, Python, JavaScript, and so on. And we have like a base image based on your application. And once you go to Java, and then you can like pull application from like your centralized Git repo, and then packaging it like for example Maven or Gradle for Java project, and then container build, and then registry, push the images into registry, and then create the Kubernetes manifest, like a bunch of the YAML file, and then deploy that thing. This is a known general development process. How do we make it better, make it secure, this process? And like a left-hand side, pretty much developer responsibility, and right-hand side, pretty much platform engineering responsibility. And now you can see a lot of tools between each step, pipeline and security, and then the digital signing, and also image check, and so on. You can see that you're going to start like a development analyst, like an extension on your VS Code, and then after you make sure everything is okay, your code level, and we're going to sign in Git commit, and then we're going to also verify your centralized Git repo before actually build application. Once you build application as a container, we're going to sign that container image, and then we're going to generate SBOM for software, secure software supply chain. And then we're going to keep doing and upload that signed and verified container image into our trusted container registry. And then we also need to do enterprise contract. Let me explain what enterprise contract a little bit later when I showcase the demo to verify the side-side compliance is that. Okay, so I just want to talk more, not going to talk more the boring slide, and then just jump into demo. So how to bring all together this kind of stuff, like a security, deployment, building, and the application development environment, and so on. So mainly, so one of the great practices is that you're going to stand up an internal developer portal. So internal developer portal, you can actually create the internal developer portal with a fantastic web UI and the backend system running on containers, something on Kubernetes, which include like a developer documentation and the CI/CD pipeline and security capability, and then like some technical documentation and so on. So let me jump into my environment. So hopefully everybody see that. So this is based on the Backstage. Backstage is one of the CNCF project. It allows to develop and create a software template. So software template is all kind of technology stack. So what kind of Git repo I'm going to use, what kind of container tool I'm going to use, what kind of application stack I'm going to use, like a Java version, and then Maven version, and then what kind of JRE version, and all needed to you for developing application, you can put it into one software template. I already created a bunch of the software template here. So software template is really a bunch of the YAML file, like a Helm chart YAML or CI/CD pipeline YAML, and also like a skeleton project, which is an application project, and so on. So like you can use like create a Java file, a Java project. You can create a JavaScript, Python, even AI application. And Spring Boot, Quarkus, or Vertex, whatever you want. So I have one thing here. Let's say, let me try to reload. Okay, let me try to do like something AI application here. So here is, I'm gonna try this one. So secure chatbot with like a LLM application. So I'm gonna start with this kind of thing. So what is my application name? Here is my secure chatbot. And then this is like a Maven property, something like that. I'm gonna do the same artifact ID. And then this is a secure AI chatbot app. Okay, I'm gonna go to the next thing. Oh, it's more than 12. Okay, I'm gonna secure chat. Make it sure. Let's go. And then the next thing is, this is an AI application. Okay, which model I'm gonna use that? Here's a model I already deploy into my internal Kubernetes platform. Here is like a Mistral IBM Granite model, and I have a fine-tuning model here. I just used my fine-tuning model today. And then here's a private container registry. You can also push it somewhere, like a Docker Hub or some of the Google registry, but I want to more use secure container registry in my company. That's why this container registry actually create some new user account for me, which allow me to push my new secure container image into this private container registry after I secure my application. And the last thing is the Git repo. So this GitLab also running on Kubernetes. And then, so basically Java developer, what is the first step starting your working in your new project? You're gonna find some centralized working Git repo project. And then, okay, I'm gonna fork that Git repo based on my account, and then clone in my local machine, and then running on IDE and the starting code. That's a known, traditional, and the practical way. So this software template actually deploy some small Git repo, copy from working centralized Git repo, and they create the account automatically just for you. So whatever you do in this repo is not going to impact any other team members' repository or the working project-wide centralized Git repo. So which means the developer, I don't need to even fork, I don't even clone into my local environment. Okay, I just review all kind of stuff, looks good to me, and just create a new software template. It takes a couple of seconds to create the software template, but behind the scene, it creates the actual infrastructure just for me. Just imagine that, okay, I'm a new hire, this is a security company, and then I need to find out and then how to install my development environment to create a new secured application. So that's exactly this developer portal enable you stand up the development environment in day one when you hired in the new company for security application development. And then when I go to like a CD, continuous deployment based on Argo CD, it already gives some multiple environment, like a reality. I needed to make sure everything is okay when I promote or tagging this my application from testing environment or staging environment, and lastly, production environment. So when I go to topology view, you can see that 3 different Quarkus application, actually the red means it's not deployed yet. It's deployed, after it deployed, it changed like a blue color, make me feel better rather than red color. And then it's like a blue, but not scaled to 1, which means it's not ready. So one is like a dev environment, one is the pre-product or staging, and one last is a product environment. I just make some scenario from development environment until product environment. And when I go to overview and then go to CI, it's a CI automatically started. This is I already created a software secure software supply chain. So it's just like I showed a couple of minutes ago, the secure this developer cycle. I really implement like a bunch of the YAML file here. As you can see, we're going to start the git clone, and then you can see that just clone the project. And the next thing is packaging application. You can see that this is a Maven Java project with the Quarkus. You can see a bunch of the dependency library downloaded first, and then it will build application in the end. Now I can see that application is built success. And the scanning is an imaging scanning. So based on using the SonarQube open source tool, and then try the multiple step. For example, when I go to a little bit down in there, you can see that there are many types of languages you can actually scan in, like a Java, JavaScript, or even HTML. But this tool automatically detects, oh, this is a Maven project. So I'm going to go to the scan like based on the Java, like a security policy and violation rules. And that's exactly happening in the next couple of minutes. In the meantime, it takes a little bit of time, like 5 minutes, something like that. In the meantime, let me try to open the application and then how that looks like. One of the good things is you can actually download this project on your local machine, but also the internal developer portal provides the Cloud IDE. This is a Cloud IDE based on VS Code. You can actually have the IntelliJ as a Cloud IDE tool. It takes less than 2 minutes to start up, because when I open new Cloud IDE, it literally starts small container on top of the Kubernetes, and then that container includes the VS Code, and then attach the Git repo, and then storage, and then it's exactly the same IDE environment what I want to use there. Okay, it's almost there. Okay, now I'm here, and I'm going a little bit bigger. And then this is a Quarkus project. Go to application. This is a chatbot using Quarkus and LangChain4j, because when I go to PalmXML, using the Java 21, and then here's the Quarkus LangChain4j and OpenAI API specification. So I'm going to connect to some model, and then that model should be compatible with the OpenAI API. If you want to using some model with some Ollama specification, I'm going to change LangChain4j-Ollama, or LangChain4j-Hugging Face, or even JLlama running on your model on JVM. And then I'm going to a little bit simple web UI with the WebSocket, and that's it. That's all I have. I'm going to try to add the first extension, what I said. You need to probably a dependency analytics. This is the security check. So let me try to find the VS Code extension here. Here we go. The Red Hat dependency analytics. I'm going to just install this extension in my VS Code. You can install any VS Code as well. And then back to the application, and maybe probably go to PalmXML. Change the PalmXML, you can see that automatically, oh, you want to open the dependency analytics, the analyzer report, and then you can see that, oh, not here. It will take some time based on your networking speed, and then because of rendering the dependency analytics report. Oh, now already I didn't do anything. I just cloned the working project repo, and I just found, oh, there are 4 vulnerabilities. I'm using the Quarkus version 3.15.1, and then there are some security breach issues, like a Quarkus REST and a WebSocket next for like a vulnerability stuff. And then, so if you want to go to more detail, you can find some kind of detail and like a CB issue. And then, it's if you developer recognize aware of this, some security breach at the very start, that would be awesome to make more security application. So we already aware, and the Quarkus engineering is aware of this kind of problem. So in order to fix that problem, you can just use a latest version, which is the most convenient and easiest way. The Quarkus minor version release every 2 weeks, every other week. So last night we released 3.19.2, and then after that, I changed that version here. And then the Cloud IDE automatically save a file. I don't need to even save a file, just like IntelliJ. And then the report will be reload soon enough. So it takes a little bit of time. Sometimes I change that. Give me 1 minute to reload. Where is that? Okay, come here. So it will come to the report generate again, and then you will see the vulnerability will be fixed there based on the latest version. So let me give it some time. All right, in the meantime, let's go back to our Cloud IDE. Here we go, yeah. So when I tested in the hotel Wi-Fi, it's a little bit faster than here. It's always a little bit like some freaking stuff. Okay, so now you can see the vulnerability is gone. So now I fixed the problem in a couple of seconds, which is really awesome. But I just revert old version because I need to make sure even if I still make a remain that error, and then probably the secure supply chain platform or some of the capability will detect the same error. That should be done in other way. So I want to show that thing as well. Okay, in the meantime, let me try to run my application locally. So using Maven and then Quarkus. Demo is provide the live encoding and pretty much easy. You're gonna whenever change the application, it automatically recompile, rebuild, and restart the application. So it takes a couple of seconds to start up Quarkus application. Now you can see that Quarkus is running, and I'm gonna open the front-end application. Here's my front-end AI body, hey buddy, and then let me ask you some. Go why sky blue in Atlanta. And then when I go back to, I got some error, which is weird. Maybe some timing error. Anyway, so go back to the pipeline stuff and then go to CI/CD. So now it's done. So before I dive into the pipeline, let me go to topology view. And then go to the same application, which is AI Buddy, and then it connect to AI model. So why sky blue in Atlanta? Probably it should work. No, something happening. My model. Okay. Try to X that. Okay, now it's the same error, which is odd. Okay. Anyway. So point is the application already deployed, and then when I go back to my ID tool, if I change something, for example, like the quickly it's not security fix, but just demo environment, I'm going to change my application, something like a title. This is a secure Java. Okay, but for that, let me try to create breach, like a secure fix, and then this secure Java code. And then back to the UI, I'm going to reload automatically, and now you can change that. And then I'm going to go to stop dev mode and then try to, okay, let's say I just fixed my problem and go to source control and then fix the security issue. And then I'm going to come in and push my code. And then back to my CI/CD and go to overview, and then here's my source code to GitLab. And now you can see that I'm going to just create a new merge request. So for that, for merge request, it's not going to automatically create a new CI/CD pipeline. And so this is security check, and then I'm going to add security check, and then probably assign someone else. And then for the demo, I'm going to use my own, and then create a merge request. And then it assigned to me directly, so I just looking at my source code to change, AI body to secure Java code. Looks good to me. I'm going to go to thumbs up and approve, and I'm going to try to merge that. Once it merges that, it automatically trigger new CI/CD pipeline, just like here. And then after that, it will deploy again. In the meantime, let me try to go back to and then take a look at more detail. So first of all, git repo, git clone, just download inside this software supply chain rather than somewhere out there. And then we're gonna build a packaging application based on Maven project. As you can see, in a minute ago, there are build success here. And then now we're going to scan source code like static analytic source code scanning based on SonarQube. There are a bunch of the language supported, and then we're going to use Java scanning stuff. And you can see that all single Java file, you can literally scan what kind of CVE, like a violation or a security issue will be detected, and that kind of stuff. And then there's no failure, luckily. And then when I go to the signing image, and then you can actually find what kind of detailed task you can find here. So let me try to do it bigger. Here we go. So there are many steps to build and signing image. So sign image using, like as I mentioned earlier, like using the 6 store is to generate new key and assign the container image based on like a vulnerability or some software component breach and so on. And then when I go to looking at more detail, you can see that the container image and using like a new SBOM stuff. And then go to upload SBOM, the trusty profile analyzer. Because once you create an SBOM based on your application, and it's going to be keep using whenever you have a new version of a container image. Because, you originally signed container image, and then after that, you're going to verify that image with some attestation or a test. And then now, in the end, you're going to match between first certified image and certified signed image and a verified image going to be matched or not. If it doesn't match, or someone actually hacked your container image. So that's always the signing stuff happening here based on SBOM. And then there are another interesting stuff here. Advanced cluster security is another tool which have a 3-step, like image scan, image checking, and deployment check. Image scan is literally checking your image for like a software component or a vulnerability. If there's something happen inside the image, and if you find that thing, return as a JSON format. So that's why I'm going to go to image scan. You can find a lot of CB stuff, important thing. We have a same CB issue, 3.15.1 version. I'm going to revert to that source code. That's why you can see that we detected this kind of stuff. So fixed version, you can see that if you use 3.15.31, this issue will be fixed automatically. So that's the one of the things. You can find more detail, go to CB issue. And then the image checking is still investigating and validate your container image itself, but it's more like a try to validate some security violation. For example, based on your company security policy, so any container image doesn't have to add on some executable file or logful shell or like a put, get, or some other package major stuff. If some utility exists inside the container image, someone try to access that container image, download some malicious code. So that's some of the policy. Image check just to validate, identify that kind of violation tool. So one of the example, you can see that there are package images inside the image. This is not impact on any application functionality right now, but at some point in the future, someone tried to just hijack the application while cracking and then download some application and malicious code and then running on, and then the application will break down. And then last thing is the deployment check. It's not validate or identify any kind of stuff inside the image, but it's checking deployment resources, like for example, Kubernetes manifest, like a YAML file. Here is one of the interesting detection here. There's no CPU request and remit or memory remit specified. So without that, you can still deploy application to Kubernetes. And then application should be running all the time. But when you have some high network traffic, the Kubernetes will automatically auto-scale your application based on HPA capability. But without max and minimum the resource capacity, your application probably doesn't have good enough resources. And then the Java application standpoint, okay, I need to at least like a one CPU and like a 256 memory, but Kubernetes doesn't have any min-max stuff, so I cannot give you good enough memory and CPU, and the JVM, we have out of memory or some kind of issue, something like that. So that's kind of thing, and then, so my application is just deploy succeed, and then now you can see that the other one, and if I go to probably load, and now you're gonna see new application, secure Java code. And now I'm gonna probably need, okay, everything's fine. I just secure my application from beginning to deployment. And now time to promote to next environment, could be pre-product or staging. And then go back to source code. I can create a new, this project, this is my project. I can create a new, like a tag here, like a v1.1, and then create a new tag. If I create a new tag and then go to CI, and it will automatically try to enterprise contract. So enterprise contract is a policy-driven workflow tool as a part of the security supply chain. So a lot of enterprise companies, they have a bunch of the security policy and rules to validate your application, the pure application and container image itself. So how do you do that? So enterprise contract, some of the like a CLI tool, and it automatically create or copy from your existing image inside your secure supply chain, and then generate new certificate key, and then validate or test your image with that certificate key, and then after that, you testing again, and the last thing that you're gonna match is tested container and with the previous original verified container image. So that is the enterprise contract is doing every single time you're gonna promote your existing application to the new environment. Now we got a new enterprise just succeed, and then just tagging, and then deploy the targeting environment, which is the pre-product environment right now. So it takes a little bit, takes some time, and once it's done, I'm gonna try to create to release this application. Again, the release title, like let's say like a secure Java code. And then when I create a new thing, I'm going to have all like a source code G file, some stuff. It's pretty much a primary job for platform engineer and IT operation team. And it will create a new, just like a new enterprise contracts again for the new environment. So if this, the last thing is here, and then go back to topology, and then now because this second environment pre-product is already running up. So when I go there, and then this is a pre-product, like a URL pre-product, and then now secure Java code is there too. And then one last CI for promote after release. So the enterprise just contract is done, and the tagging again, and then push the new image into secure container registry, and then patch deployment into new environment, which is a production. And then this will coming up soon enough. And then once it's soon enough, and then my secure software supply chain just completed from beginning to the end. So now we have a new application in production, and then go to here, and now you can see that here's a production URL, and now we got the same application here. I just changed some simple thing, but in reality, you're gonna fix the security application as a developer, and then you're gonna just try this internal portal, and then you can find and verify how your application deployed to the multiple environment. Okay, that's all I have today, and then you're probably really hungry, right? So yeah, thanks for coming today, and if you have any question, just let me know. And again, thanks for coming. Have a wonderful day. Thank you.